Hi, welcome back. I think in the morning we were discussing, or probably in the in the very last meeting we were discussing about the approach for the problem that we were solving. I think the problem was, mm, yeah, image smoother, I guess, and yeah, tell this place we saw, and also we were getting the result, but the problem was, of course, the when we are submitting it, it's not accepting, but if we are running it, it is working. And I also tried to run this locally, and locally it is working. And for the uh, area, like so the code for which it is saying like it is out of bound. I can see, let's say if I is 0 and j is 0, that's how like the code will come here. But if I is 0 and j is 0, I'm never subtracting anything from the either I or 0. So all in all, I have no clear picture of what's happening. Okay. So now, like once I give a try by myself, like in order to attempt it, what I will do, I will try to now get the answer from the um, any one of the LLMs probably. Okay. So yeah. So what's the approach? Oh yeah. I think in one of the questions, like I have seen this approach, and the question was, I am not remembering, probably it was related to DFS or BFS, but yeah, the code, the way of writing the code is in this direction, like is in this way, and it enables to um, quickly iterate through all the combination. I will talk about it, but let's see what's the approach they have. Let me do side by side so that you can see. It's my code. I think there is a focus mode. Okay. Yeah, sorry. So now let's see if it is how much is matching. So again, I get the dimension MNN, that's fine. And then what we are doing here, result 0 cross n for linear. Okay. So here what we are doing, since we are aware of the dimension of the since like we can like pre-compute what's the dimension of the result is going to be, and we know that's going to be the same. So that's essentially we are doing here. So we are pre-calculating how the result will look, and what we are doing here is like so how many rows are there. So for these many rows I'm going to iterate, and for each row I will have three number of zeros, like three number of okay. So what does this mean? It means zero would be repeated, not three different element, but okay, single list with three different element. Okay, all are zero, not the list. Okay, thereafter that's the main part for I in. Okay, so okay, let's try to morph it around. Okay. So I can also prepare my list. In my list, instead of now this approach, we are already pre-computing it. So I can do 9 and in range M. That's correct. Okay, so now this L is gone, and now this will enable to like directly modify the index place. Okay, so till now we were relying on appending things, but by doing this approach, we would be able to I think like modify the index places. Okay, let's keep this part out of the course for brevity. Yeah. So of course this is not required anymore if you remember why we kept it here. Okay, so we have M, N, and L. I am just calling it L. Okay, for I in range, that's correct. Now he has a total and total divided by, in our case that is temp. In our case that is temp, and count is equal to 0. What is count equal to 0? What does it mean? Okay. So somehow they are also keeping track of how many neighbors are there. Anytime they are encountering a neighbor, they are preparing the count. Okay, so they are dynamically calculating this 4 also. Okay, and then the like the rest of the part is same. So uh, why is not using the floor? Mm, Is it default? Not sure, but will not. Okay, so so temp, which is divided by something. In our case, this is the result, and instead of now going at this approach, I can go L I comma J is equal to well. Okay. Now let's modify this whole of the logic. Okay. So what are the things which remains the same? I'm still maintaining the same variable just because I was using this one only. Okay, and in the first case let's rename it probably just to give you a better picture. Okay, let me name it as sum of surrounding. Okay, sum of surroundings, it is 0. And the second thing which I can write is okay, so first is sum of surrounding, second can be um, number of neighbors. Number of neighbors and neighbors are 0. Okay, so both of these two values needs to be computed, and once I have that, what we will do something sum of surrounding divided by I think I have a very strong feeling that this floor is not would be required, and I think directly we can use this I think this operator, I think it gives without denominator. We can probably just we will check it in local. Okay. So all in all, this is the approach. Now, the most important part, like I know, like you might have not seen this approach, but probably some of you might be familiar. But this, I think, when the first time I saw I saw this approach. It was very fascinating for me. Like it's very intelligent. I feel like as per me it was intelligent. Okay, so instead of like typing I plus j, I plus one, I minus one, or j plus one, something. Instead of doing this, just to top down something like that. Okay, so let's see. It may okay. So what does dx mean here? For dx in let's say negative one, 0, and 1. Okay. What does it mean? Like tell me what you think. Okay, so let me do one thing. Form and so okay. We have practice. Sorry, this question is empty. Yeah, it is. Okay. So this. Okay. Now, our assume like our matrix is also this means uh, like from top to bottom, zero row, first row, second, third, fourth, fifth, sixth. Okay. And now let's look at the code. Dx. Okay. Suppose I am here. Yeah. So what's the next row? What's the next row index? What's the previous row index and what's the current index? Think in that direction. So current would be let's say this, previous row would be this, and the new row would be this. Okay, this is the only combination. And the main intent is what to add or subtract from the current row index to get to the previous row. Okay. For example, let's say I'm here. What I need to do in order to go to the previous row, I need to subtract one. What I need to go on the current row, I don't need to add anything. I have plus zero. What I need to do to go to the next row, I need to plus one. Okay, same logic. So these three are covered, and now we will cover this. Like it's a combination. Like the best example, probably if I can show you, wait a second. Five, first one. So let's see this. So, okay, I think like it- because I think this pattern is a very very important. Not the pattern, but the way of writing it. It's very intense. Okay, for let's say uh, x in 40, x in 1, sorry, minus 1, 0, and 1, and then for dy in minus 1, 0, and 1. Okay, same thing applies here. Now let's say print dx. Okay, you will see all the patterns. Negative 1, negative 1, negative 1, 0. Okay, so you see all the pattern. So okay, what it means like it is means like it is going to like these things would be subtracted from the actual excess value. So minus 1 will be subtracted from the I, minus 1 will be subtracted from the j. Okay, let's go back and see here. Okay, so this is the pattern, and now what's okay, let's go for dy in negative 1, 0, 1. Now what is this? New I and new j. New I, new j. Okay, okay, okay. It's like the temporary Muslim value of that. New I and new j. Okay. So, in a way, what this statement means, uh, this surrounding. Okay? So, these are the coordinate of the new surrounding. I plus dx, j plus d. Okay. Once I have this new I and new j. Okay. So So now, uh, if you remember, like in when I was solving it out, for me the major problem was like, how do I know if certain surrounding exists or not? For example, when I am on this, I know the outer surrounding do not exist. Okay, and if I'm let's say here, I know all the surroundings are here, and if I'm here, only six surroundings are there, not the three. Okay, in case of corner, if you remember, we had kind of three surrounding. In case of edge, we had kind of one, two, three, four, five surrounding. In case of anything in this, like in the uh, just after the one row and one column, like the surrounding would be nine. So now how this code is solving like that, let's see. So okay, so till now what we did, okay, let me do one thing. Okay, so for example, let's say I would have said for I range yeah, for J range for, let's do this. What, what's happening now? We can do one thing, right? For for yeah, something else. So what is happening? You see a long piece of code. You getting? So like after all of these are done, I'm getting a long piece of code. And what is happening? If you try to see, these are the okay. Just count it. Okay, what? Where is that? Count it. 1, 2, 3, 4, 5, 6, 7, 8. Till 8 here, 9. Okay, let's go about 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and in one row there are like four elements. Okay, so 436. So currently what is happening, for every cell, I I have some value of okay, let me do one thing. Okay, so like now for every cell, I have calculated what I need to plus and minus in order to get the in order to get the in order to access those surrounding elements. Okay, I'm just trying to uh, mm, just trying to get the how can I access those? Okay, I'm not accessing those. I am just trying to find their addresses. Okay, till now what I have done, like I have tried to find out by what logic I can do. It's like plus one minus one. That's all. Okay, but their addresses are not this. Okay, what are their addresses? Their addresses are I plus and j plus. These are their addresses actually. Okay, so but problem here you will see minus one and minus one will not exist. No, so these are their exact address, and like now you see these are very different. Like these are not symmetrical anymore. But the catch is, I know like 1, 2, 3, 4, 5, 6, 7, 8, 9, some let's say this much. And you know, these are all the possible surroundings addresses of the very first cell. Okay, but the catch is negative one will not exist. Negative negative of anything will not exist, right? Yeah, and do you think it's uh, I feel like now it's clicking in my mind that I should have thought in this direction also, because negative of anything will not exist. Okay. And somehow if I'm able to filter filter out this thing, I think that can be a good thing. Let's see. Let's see. Let take a think. What's the condition? So new of should be between this and new of j should be between this. And Yeah. Cool. Okay. So the condition which is saying is that this value should be between 0 to, okay, let's do one thing. Let's call it m equal to 4, equal to 4, and and okay, if this value is this, okay, what was the other condition? And 0 less than g plus dy less than n, n will be 20. So 0 less than, of course, it will not reach the. So, yeah, like of course, I also know like that this is a very, whenever like equating or like dealing with indexes like sometimes tough for me still till this state. But yeah, in this case, I can immediately think that yeah, uh, n will not be the scenario. Okay, it should also be this. Now let's try to now let me do one thing. Let me add something. So print column identity. Okay, so that I will immediately know when the column is. Okay, so now you see only four in total, three surroundings are there for the what we say for the very first 0 0. Okay, let me do one thing for I comma j. So one okay, how's this? Again, now let's see. What are the surroundings are this? For 0 comma 1, how many surroundings are there? Six surroundings should be there. 1, 2, 3, 4, 5, 6. Hmm, I think that's good. And for some inner element, the surroundings would be 9, 1, 2, 3, 4, 5, 6, 8, 9. Ah, that's a very clever approach. Now, once I have the surrounding, I can do this anyhow. Let's let me put this if and that's what I feel like. Should I write like how I have written over here? Only catch is like I can write, but the problem is uh, I need to repeat it. But yeah, let's take understanding. Let's prioritize understanding more of the syntax part. Right. So uh, let's take this if you collect it like exactly this. Boundaries are gone now. If this is correct, I'm getting correct neighbors. Now for those neighbor, anytime this will like I now I just need to compute the some of the surroundings. Okay, I need to add the value of that particular x. What is x? Sorry, d I and then surrounding. Okay, once this is done, I'm out of like for any given cell. Once I'm doing with the how many number of surroundings are there, how many number of cells are there. I think now do something. Means oh, So good. Where is the result? Start submitted. Oh, good. Okay. So I think, yeah, this is the solution. And yeah, this question was indeed very, very good in terms of thinking structurally and uh, approaching the problem in a different way, or like finding the patterns. Very, very good focus. Good. Okay. So it's the second same approach. Yeah, so this was the morning approach, and this is the second approach. Yeah, I have solved it like previously, some questions also previously, but yeah. Anyways, I just from now on we try to be consistent with everyone, because core intention is, of course, the like, followers like you or subscriber or like whoever is the viewer of this video can get some sense of confidence and like some sense of patience when trying to solve this problem, because ultimately this is rewarding in real life, not when doing this on. Thank you so much for this like, uh, follow till here, and probably this was a easier question, so there would not be any further part on this question, like further video on this question, but probably on a new subject. Okay, thank you so much.